So when it comes to specifications for OneMoji, because it's a module for a greater assistant, we wanted to be able to train to individual user. So the machine should have a sense of who its owner is, how its owner behaves, what kind of language the owner uses, what kind of facial expressions that the owner is most likely to have, and what kind of problems that the owner is most likely to solve. So the chat assistant should have a good knowledge of what its user is. So the training data needs to come from its owner. And the training data needs to be small enough that it's easy for the owner to provide and it's easy for the machine to train. That's one thing. And the other thing is we want this assistant to be very quick on its feet. So it doesn't need to think for long periods of time and respond, because that's just not real-time performance, and usually that tends to be bad. And the problem, and this is our problem with deep learning as of now, is that just training takes multiple GPUs and running for multiple days, and that's probably too long for us to expect. So there are two models to deep learning as is used today. What happens is we can have a mobile device as a thin client that's connected to the network, and the mobile device captures the data and sends the data to the server to process. And the server does the training, saves the model, and does the prediction on the server side. So the mobile device is simply taking images and returning images, or if it's sound files, it's just taking sound and recording sound and returning results. So the mobile device itself is not doing much. Another approach is to have the model trained on the server, and after the server trains, it sends the model back to the mobile device. So the training will be done on the server, but after the model is trained, the model is on the local device, so the user can do prediction locally on the client. So that's another way to do it. Our design goal is actually to have both training and prediction all on the client device. So this mobile device is a rich client as opposed to a thin client. So we'll do all the computation on the client side and return the results. And we feel that in the near future, mobile devices should have this kind of computing power. So, and that's sort of the motivation of why we want to do everything locally. But the state of art doesn't allow that. If no mobile device has multiple GPUs to be trained for a couple days, that's crazy. So, and for that reason, it made choosing CNN a very, very difficult choice. And that's why we decided not to choose it. Mainly because it does not allow training and prediction training to be done on the local side, and also the training data is really, you need a lot of training data for it. And with these two factors, we had to look elsewhere for a solution, and that's why we decided to search for a specific face detection algorithm that is not deep learning and can achieve similar results but meet both of those criteria. So we went to OpenCV and looked at its face recognition class, and we were able to find the LBPH. This algorithm has been around since 2000s, and basically what it does is it uses a binary image histogram to find the facial features. So while it is good, there were a lot of issues that we had to take care of it ourselves. We find that deep learning is kind of it's like a kit you get from a store. It comes with everything, and it takes care of all the problems that you might face in the future, and it's a big black box kit that covers everything for you. Whereas if you wanted a specific algorithm, in this case, you have to take care of the cases yourselves. And I'm going to talk about what cases that you face if you're going to pick a specific algorithm, some of the things that you need to handle.